This is Mrs. Tran-Bloom. I am recording 6.3 notes, graphing cube root functions. So as you can see here, the name of our function today is cube root. The parent function, it's always, remember, the parent function is always the most simplest function. We are stripping away the a value, the h value, and the k value. The HK form is very similar to the other forms where the A is going to be in the front, the H value is going to be inside, and then we add the K value at the end to indicate if we have a vertical shift. That means it's up or down. So the first thing we are going to do is to graph out the parent function. Very similarly to the others, guys, we are going to start with some inputs values. We are going to start with a -8. Yes, cube root can have a negative input. Then we're going to do -1, and then we're going to do 0, 1, and 8. As you can see, we are using 5 inputs value. Now, cube root of a -8, students, is going to be -2, because if you think about it, -8 inside is the same thing as saying -1, cube root of -1 times cube root of 8. So cube root of -1, students, is going to be -1. Now, cube root of 8 is 2. So when we multiply those together, it's going to be -2 is the answer for cube root of -8. Cube root of -1, just like what we just talked about, is going to be -1. Cube root of 0 is going to be 0. Cube root of 1 is 1, and cube root of 8 is now 2. So these are the 5 inputs that we are going to use. This is the output for -8. This is the output for -1. This is the output for 0, the output for 1, and the output for 8. Now we are going to plot those points right here on the grid. So -8 goes to -2. -1 is going to be -1. 0 is 0. 1 is 1. And then 8 is now 2. So think of it as a sideways snake. Okay, now if we can't see the dot, make it super fat so your teacher can see it, just like that. The H and K, it is not a vertex, guys. This is an inflection point. So inflection point, because it's not a max or a min, it's an inflection point, and it's, again, it's the H comma K value. So our inflection point is 0, 0, because we do not have any translation left or right or up or down. The x-intercept is at 0, 0. The y-intercept is at 0, 0. Your domain is going to be all real numbers, or we can write it from -infinity to infinity. Your range is very similar. It's, again, all real numbers, or we can write it from -infinity to infinity. For the parent function, it is increasing the entire time. Remember, increase and decrease, it's going to be a little bit difficult for some of you still. Increasing is meaning that if we are going to go from left to right, okay, is the y value going up? So that means if the y value goes up, that means it is increasing. If it goes from left to right and the y value goes down, that is decreasing. So the entire domain is now for increasing, so decreasing is NA or non-applicable. It is a one-to-one function, guys, because it is going to give us, it passes the horizontal line test. That means every single time we make a horizontal line, it only intersects the function at most one time. We do not have a minimum point or maximum point because we do not have any vertices, okay? And that's as simple as a parent function. Let's go and do the transformation refresher. So as you guys remember already, if A is negative, that is a reflection over the x-axis. Reflect over x-axis. Now sometimes some of your teachers or some of your friends will also call this a vertical reflection. So vertical reflection, okay? Now, if your value, the absolute value of A is less than 1, it is a vertical compression. So vertical compression factor of whatever that is. So if it's 1/2, then it's 1 the vertical compression of a half. If it's a 5, then it's a vertical stretch because it's bigger than 1. So it's 1 over a, whatever that is. Okay, so let's call it IE. A is 1/2. So it's a vertical compression of a half. So 1 over 2. If, for example, AIE, A is going to be 5. Now that's bigger than 1. So I'm going to abbreviate vertical. So VS stands for vertical stretch. Okay. Vertical stretch factor of A. Okay. Of A value, whatever that is. In our case, is factor of 5. Your H value, if H is negative, okay, H negative, it's going to tell us to go left, that however many units. If H is positive, then it's going to go right, that many units. Okay, so right H unit, and then left H unit, however many units that may be. Okay, now K, if K is negative, we are going to go down K units. If K is positive, then we are going to go up K units. Steps to graph any function in HK form. So guys, these are very similar to the previous, okay? So first we want to identify the parent. Is it cubic? Is it reciprocal? Is it radical? Is it so on and so on? And then make a table of value for the parent function. Once you have identified A, H, and K, we now want to use those and transform your table. You will be asked to make a list of your transformation. And then once you have your transform table, we are going to use those to plot. And then, of course, you need to identify or find all of the characteristics. Okay. We have 2 examples left. Let's rock and roll. Example 2 and 3 says, graph each function, then find all of your defining characteristics. So your A value is in the front, so we're going to write A is 4. A is not A is 4. You do not have any H value. So look at this. Can you guys see that there's only an X under the cube root? So H is 0. Then you have one K value, which is the one that's outside of the cube root. That's going to be -5. So again, I'm going to quickly make the parent chart for you here, so we don't have to go up and down. So if you can remember, here's your parent function, right? We have 5 inputs. Now guys, you should not have to memorize these, okay? So parent function is just cube root of X. So 5 inputs. These are them. Now, you should not have to memorize any of these. You just have to plug it in and then get your value manually. So cube root of -8 is -2. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So we are now going to use it to make our transform function. I'm going to make my pen a little bit skinnier. Okay, so we have an H of 0. So X plus 0 or X minus 0, it's just still X. Then 4 times Y minus 5, because your A value is going to be multiplied to Y, and then we add or subtract K. So all of these X values should be exactly the same. So that should be -8, -1, 0, 1, and 8. Then all of your outputs will need to be multiplied. Oops, that's our bell. We need to be multiplied to 4 and then -5. Ready? -2, okay, times 4 is -8. -8 minus 5 is now -13. -1 times 4 is -4, minus 5 is -9. 0 times 4 is 0, minus 5 is -5. 1 times 4 is 4, minus 5 is -1. And last one, 2 times 5 is 8. 8 minus 5 is 3. So we are going to plot this right here. This is your transform table. And -8 is now -13. Yeah, you can add 3 more tick marks. No big deal, guys. Okay. -1 is now -9. 0, 2, 4, 5, -5. 1 is -1. 8, go up 3. And remember, it looks like a sideways snake. So this one, because it vertically stretched so much, it looks more like an S, right? So that is our cubic function. Our h and k is going to be 0, -5. We have an x-intercept somewhere, as you can see here, but we can't eyeball it, so we're going to work it out manually. Are you ready? X-intercept, I'm going to, let's see, where should I do the work? How about right here on this side? X-int is when y equals to 0. So 0 equals 4 times cube root of x minus 5. First thing we want to do is add 5 to both sides. So 5 equals, oops, let me make this pen a little bit thinner. 5 equals 4 times the cube root of x. Remember, we want to isolate your radical, so divide both sides by 4. So 5 over 4 equals cube root of x. To get rid of the cube root, we raise it to the power of 3. We do its opposite, okay? So now we have 5 to the third is 125. 4 to the third is 64, which equals to x. That is in the simplest form, so we're just gonna leave it like that. So x-intercept, it's gonna be 125 divided by 64, 0. Y-intercept is when x equals to 0. Well, I have a table that has that value, so we're just gonna go and write 0, -5. Now, as you guys remember, the parent function has a domain of all reals. So this one will also have a domain of all reals, or sometimes we write it from -infinity to infinity. The range is the same, -infinity to infinity. This is an increasing function, guys, because you are hiking up, right? As we're going to the right, the y value gets higher and higher. So it's increasing the entire domain, so -infinity to infinity. So that means there isn't anything left for decreasing, because every single value in the domain is already reserved for increasing. It is 1-to-1. All cubic function is 1-to-1. We don't have minimum or we don't have maximum because we do not have vertices. We do have transformations that we need to state. We technically have 1 and 2 kind of transformation. The first one is the 4. So it is a vertical stretch factor of 4. Okay, it is very important to indicate it's vertical or not, because next year you will also have horizontal. Next is going to be the -5. So we are shifting down by 5. Shift down 5 units. Or you can write down 5 units is fine. All right, look at that. Not too bad. Let's go on to example 3. Example 3 has a -1 in the front, so that's going to be your -a. So a is -1. We have inside a value of +2, but we have to take its negative, its opposite. So h is -2, and then we have a -7 on the outside, so that's reserved for your k. All right, so immediately your inflection point is going to be -2, -7. Technically, guys, we can do the parent again, so we don't have to look above. So let's do it really quickly. -8, -2, -1, -1, 0, 0, 0, and 1 is 1, and 8 is 2. Then we are going to use this color to do our transform. Your a is -1, so -1 times y. Your h is -2, so x minus 2, and then we're going to -7 from here. We are going to take all your x's and -2. Are you ready? -8 minus 2 is -10. -1 minus 2 is -3. 0 minus 2 is going to be -2. -1. 8 minus 2 is going to be 6. Now that's done. Next is going to take all of your parent y and transform it. So that should be -2 times -1 is going to be 2. 2 minus 7 is going to be -5. -1 times -1 is 1. 1 minus 7 is going to be -6. 0 times anything is 0. Minus 7 is -7. 1 times -1 is -1. Minus 7 is going to be -8. 2 times -1 is -2. Minus 7 is -9. So, guys, we now have this to plot. Okay? All right, -10 is going to be -5. -3 is 2, 4, 6, -6. Then we have negative 2. Oops, that's not negative 3. Negative 3 is negative 6. Negative 2 is negative 7. Negative 1 is negative 8. Then 6, 2, 4, 6 is negative 9. All right. As you can see here, we are now starting on the top left because we have a negative for an a value. So we are reflecting, okay? So x-intercept, we do need to find it, okay, guys? This point right here will eventually go and hit the x-axis somewhere over here, somewhere far. So I'm going to expect a very, very big negative number. So we have to work that out manually. So we are going to look for x-intercept manually, okay? When y equals to 0. So let's rock and roll. 0 is negative cube root of inside x plus 2. And then outside is minus 7. We are now going to add 7 to both sides. So that's going to be plus 7 plus 7. Next would be dividing by a negative 1. So now we have 7 equals a negative cube root of x plus 2. When we divide negative 1 to both sides, we have now negative 7 equals cube root of x plus 2. What do you think we need to do next to get rid of our index of 3? I hope you said raise it to a power of 3. You are correct. Negative 7 to a power of 3 is still going to be a negative number. So it's negative 7 times negative 7 times negative 7, which is a negative 343, guys, equals to x plus 2. The last step is to minus 2. So if we minus 2 from both sides, it's going to be a negative 345. Oh my, that is a very big negative number, which we are expecting it. So we're going to go and write x-intercept negative 345, comma 0. Y-intercept, we have to find this manually because it is not shown on our table. So y-int is a little bit easier. It just when x equals to 0. So when x equals to 0, the only thing that's left under the square cube root, guys, is x. Well, that's good, 0. So 0 plus 2. So the only thing that's left is the 2. So y equals negative cube root of 2 minus 7. That is an exact answer. So we're going to leave it just like that. So 0, comma, negative cube root of 2, take away 7. Okay. Now, hopefully you guys know how to use a calculator as well. If you know how to use a calculator, you can also get an approximation, but most likely an exact answer just fine, unless it's state round to certain answer. Okay. We know that the domain and range for all cube root function is all real numbers, aka from negative infinity to infinity. Now, we now have to decide if this is an increase or decrease, okay? So remember, we are always going to go from left to right. If we're going from left to right, can you see that we are going downward? So if we're going downward, that is going to be a decreasing interval from negative infinity to infinity. So that means it's the entire domain. So that is that, okay? Increasing, there's nothing left, so we're going to write NA. It is definitely a 1-to-1, and we do not have any min or max because we do not have any vertices. We do have a few transformations of state. So the first one is the negative 1 for a value. So reflect over x-axis, okay? And then the next one is negative 2. That's going to go left 2 units. Then the next one is going to be down 7 units. And I'm going to pinch it in. And that's it, guys.